Hi everyone, welcome to my lecture. In this chapter, we will focus on two fundamental concepts in quantitative research, which are validity and reliability. These concepts are important because they help researchers determine whether the data collected are meaningful, accurate, and trustworthy. In research, data only become valuable when they correctly represent the concept being studied and when the measurement process is consistent. Validity focuses on whether we are measuring the right concept, while reliability focuses on whether the measurement gives stable and consistent results. Many beginner researchers concentrate heavily on data analysis and statistics, but they often overlook the quality of the measurement itself. If the measurement is weak, even the most advanced analysis will not produce useful findings. Therefore, before designing questionnaires, surveys, or tests, researchers must understand validity and reliability to ensure that their study is built on a strong foundation. Validity refers to the degree to which a research instrument measures what it is intended to measure. In simple terms, validity is about accuracy. When researchers discuss validity, they are asking whether the instrument truly captures the concept or construct under investigation, rather than measuring something else. Many research concepts, such as satisfaction, motivation, stress, or information literacy, cannot be observed directly. As a result, researchers rely on instruments like questionnaires or tests to represent these abstract ideas. If the instrument does not accurately reflect the concept, the data collected will be misleading and the conclusions drawn from the study will be incorrect. Validity is therefore a central concern in research and must be carefully considered during the design of any measurement tool. For example, if a study aims to measure students' academic stress but most of the questions focus on leisure activities, the instrument does not validly measure stress. Validity is not limited to the measurement instrument alone. It also involves the overall research design. Measurement validity focuses on whether the responses collected truly represent the concept being studied, while research design validity focuses on whether the results can be logically linked to the independent variable. A well-designed study reduces the influence of external factors that may affect the outcome. In social science research, human behavior is influenced by many variables, and failure to control these variables can weaken the validity of the findings. Researchers must therefore carefully plan their study procedures, sampling, and data collection methods to ensure that the results are meaningful and credible. For example, if a study examines the effect of online learning on academic performance but students are also receiving extra tutoring, it becomes difficult to determine whether online learning alone caused the improvement. There are two major types of validity that researchers must understand, namely internal validity and external validity. Internal validity refers to whether the observed results in a study are truly caused by the variables being examined and not by other uncontrolled factors. It focuses on cause and effect relationships within the study. External validity, on the other hand, refers to the extent to which the findings can be generalized to other populations, settings, or situations beyond the study sample. A study may have strong internal validity but weak external validity, or vice versa, depending on how the research is designed and conducted. For example, a study conducted using one class of students may show a clear relationship between variables, but the findings may not apply to students from other universities. Validity is often described as accuracy in measurement because it reflects how closely a measurement represents the true value of a concept. Researchers assess validity by examining whether an instrument aligns with relevant theories, expert judgment, or previously validated instruments. A valid instrument provides confidence that the data collected genuinely reflect the phenomenon being studied. Without validity, data may appear organized and detailed, but they do not represent reality. This is why validity is considered a fundamental requirement in research measurement and evaluation. For example, if the results of a library satisfaction survey match actual service usage patterns, this supports the accuracy and validity of the measurement. Internal validity focuses on whether changes in the dependent variable are truly caused by the independent variable. A study has strong internal validity when alternative explanations for the results have been minimized or eliminated. Achieving internal validity requires careful control of variables, clear research procedures, and logical reasoning. Without internal validity, researchers cannot confidently claim that one factor caused changes in another. Internal validity is particularly important when evaluating programs, interventions, or training effectiveness. For example, if students perform better after a training program but their prior skill levels are not considered, the improvement may not be caused by the program itself. Measurement validity can be further understood by looking at the different ways researchers evaluate whether an instrument truly measures the intended concept. Common types of measurement validity include face validity, content validity, criterion validity, and construct validity. Face validity refers to whether the instrument appears reasonable and appropriate at first glance, based on logic or judgment. Content validity focuses on whether all important aspects of a concept are adequately covered by the instrument. Criterion validity examines how well the instrument compares with an external standard or benchmark, either at the same time or in the future. Construct validity considers whether the instrument behaves in a way that is consistent with theoretical expectations. Together, these forms of validity help researchers judge the overall quality of a measurement tool. For example, a questionnaire intended to measure information literacy should include questions on searching, evaluating, and using information, not just one of these skills. External validity refers to the extent to which the findings of a study can be generalized beyond the specific group or situation being studied. It addresses the question of whether the results can apply to other people, settings, or time periods. External validity is closely linked to sampling methods and research context. Studies that use representative samples and realistic research conditions tend to have stronger external validity. However, achieving strong external validity can be challenging, especially in small-scale or classroom-based research. Researchers must balance practical limitations with the need for generalizable findings. For example, findings from a study conducted only among first-year students may not be applicable to postgraduate students or working professionals. Statistical validity concerns whether the statistical conclusions drawn from the data are accurate and appropriate. Even when an instrument is valid and reliable, incorrect statistical analysis can lead to misleading results. Statistical validity requires that researchers use suitable statistical tests and ensure that the assumptions of those tests are met. Problems such as small sample sizes, inappropriate data types, or violations of statistical assumptions can weaken statistical validity. Researchers must therefore understand the nature of their data and select appropriate analytical techniques to support sound conclusions. For example, analyzing ordinal survey responses using statistical tests meant for continuous data can distort the interpretation of results. Invalidity can arise from several sources in research. One common source is incorrect or weak theoretical assumptions, where the researcher misunderstands the concept being studied. Another source is poorly designed instruments that measure something different from what was intended. Ambiguous questions, unclear wording, and multiple interpretations of responses can also lead to invalid results. Identifying and addressing these sources early in the research process is essential to ensure meaningful findings. For example, using attendance records as the sole indicator of student engagement may be misleading if students attend classes but do not actively participate. Reliability refers to the consistency and stability of a measurement tool. A reliable instrument produces similar results when used repeatedly under similar conditions, assuming that the concept being measured has not changed. Reliability helps reduce random measurement error and increases confidence in the data collected. However, it is important to note that an instrument can be reliable without being valid. Consistency alone does not guarantee that the correct concept is being measured. For example, if students provide similar responses when answering the same questionnaire on different occasions, the instrument demonstrates good reliability. Reliability refers to consistency in measurement and focuses on whether a research instrument produces the same results when the measurement is repeated under the same conditions. In simple terms, reliability asks whether a test, questionnaire, or measurement procedure is dependable. If the conditions have not changed and the concept being measured remains the same, a reliable instrument should give similar results each time it is used. Reliability is important because inconsistent measurements introduce random error, which reduces confidence in the data and weakens research findings. When researchers ask how reliable an instrument is, they are asking how much they can trust the scores produced by that instrument. Reliability does not tell us whether we are measuring the correct concept, but it tells us whether the measurement itself is stable and repeatable. Without reliability, it is impossible to evaluate the quality of a measurement or to compare results across time, individuals, or studies. For example, if a hearing test is administered to the same person using the same equipment in a quiet environment and it produces very similar results each time, the test is considered reliable. However, if the results change significantly each time without any real change in hearing ability, this indicates that the measurement procedure lacks reliability. When a measurement is reliable, repeated use of the same instrument with the same subjects will produce identical or highly consistent scores, as long as the object or phenomenon being measured has not changed or has changed in a known and expected way. This consistency indicates that the measurement process is dependable and not influenced by unpredictable variation. Reliability is closely related to the degree to which a measurement is free from random error. Random error occurs when results fluctuate due to unclear items, inconsistent administration, or external distractions. When random error is minimized, the measurement yields more consistent results across repeated uses. Reliability therefore reflects the stability and consistency with which an instrument measures a particular concept and helps researchers evaluate the overall goodness or quality of the measurement tool. A measurement that lacks stability or consistency cannot be trusted to produce dependable data, even if it appears well designed. For this reason, reliability is evaluated by examining how stable the results are over time and how consistently the instrument behaves when measuring the same concept. For example, if a student completes the same skills test twice within a short period and their actual ability has not changed, the scores should remain very similar. If the scores are stable across both attempts, this shows stability. If different parts of the test produce results that align with each other, this shows consistency. Reliability refers to the idea that when a measurement is used repeatedly with the same subjects, it should produce identical or very similar results, as long as the subjects and conditions have not changed. In other words, a reliable measurement tool gives consistent scores each time it is used. This consistency allows researchers to trust that any differences in results are due to real changes in the subject being measured, rather than mistakes or random variation in the measurement process. Reliability can be improved in several important ways. First, clear conceptualization is needed, meaning the researcher must clearly understand and define what is being measured before designing the instrument. Second, precise measurement helps improve reliability by ensuring that questions or items are clearly written and interpreted in the same way by all respondents. Third, using multiple indicators to measure the same concept reduces the influence of random error from any single question. Finally, pilot testing allows researchers to test the instrument on a small group first, so that unclear items or problems can be identified and corrected before the actual study is conducted. For example, if a questionnaire is designed to measure students' study habits, the researcher should first clearly define what study habits mean, use several clear and related questions to measure the concept, and test the questionnaire with a small group of students before using it in the full study. This process helps ensure that the results remain consistent each time the questionnaire is used. There are three common types of reliability used in research to examine whether a measurement produces consistent results. The first type is test-retest reliability, which focuses on consistency over time. This type examines whether the same measurement instrument produces similar results when administered to the same subjects on two different occasions, assuming that the object or phenomenon being measured has not changed. For instance, if a questionnaire measuring students' learning motivation is given to the same group of students at the beginning of the semester and again 2 weeks later, and the scores remain very similar, this indicates good test-retest reliability and shows that the measurement is stable over time. The second type is inter-item reliability, which is based on the correlation among several related items that are designed to measure a single concept. When inter-item reliability is high, it means that the items work together consistently and are all measuring the same underlying concept. For example, if a survey includes several questions intended to measure study habits and students who score high on one question also tend to score high on the other related questions, this shows strong inter-item reliability. The third type is inter-rater reliability, which examines whether similar phenomena are rated similarly by multiple observers. High inter-rater reliability indicates that the measurement results do not depend on who is doing the rating. For example, if two lecturers independently assess the same student presentation and give very similar marks, this demonstrates good inter-rater reliability. The relationship between validity and reliability can be understood by looking at four possible combinations of measurement quality. A measurement can be reliable but not valid, valid but unreliable, neither valid nor reliable, or both valid and reliable. When a measurement is not valid but reliable, it means the instrument produces consistent results, but it is consistently measuring the wrong concept. The scores may be stable, but they do not represent what the researcher intends to measure. For example, a clock that always shows the same wrong time is reliable because it is consistent, but it is not valid because it does not show the correct time. When a measurement is valid but unreliable, it means the instrument measures the correct concept, but the results are inconsistent and unstable. In this case, the measurement sometimes reflects the concept accurately, but the lack of consistency makes the results difficult to trust. For example, a weighing scale that sometimes gives the correct weight and sometimes gives very different readings for the same object may be valid in principle, but unreliable in practice. When a measurement is not valid and unreliable, it neither measures the correct concept nor produces consistent results. Such measurements provide data that are meaningless and cannot be used for analysis. For example, a poorly designed questionnaire with unclear questions may produce random answers that do not reflect the intended concept and also vary widely each time it is used. Finally, when a measurement is both valid and reliable, it measures the correct concept accurately and produces consistent results across repeated use. This is the ideal situation in research, as the data collected are both accurate and dependable. For example, a well-designed test that consistently measures students' actual knowledge level each time it is administered demonstrates both validity and reliability. Validity and reliability matter because all research is built on data, and data form the basis for analysis, interpretation, and decision-making. In research, data are not collected randomly. They are gathered through specific measurement procedures such as questionnaires, tests, observations, or instruments. The scores produced by these procedures only have meaning if they truly measure what they are supposed to measure, which relates to validity, and if they do so with accuracy and consistency, which relates to reliability. If a measurement lacks validity, the data do not represent the intended concept, and if it lacks reliability, the data cannot be trusted because they are inconsistent. As a result, evaluating whether data are valid and reliable is a key element in applying research findings, especially when making conclusions, recommendations, or decisions based on the results. Researchers therefore examine the quality of their data before interpreting outcomes. Statistical techniques play an important role in this process, as they are used to test and evaluate the reliability and validity of data, helping researchers determine whether the measurements are strong enough to support meaningful conclusions. This slide highlights how reliability and validity are evaluated in research and why both are essential for producing meaningful data. From the perspective of reliability, the key question is whether the value that is observed and recorded accurately reflects the true value of the object being measured. This is examined by measuring the same object multiple times or using different measurement approaches to see whether the results remain consistent. Because of this requirement, every researcher must either use an existing, well-established instrument or test and demonstrate the reliability of a new measurement tool before applying it in a study. Conducting a literature search plays a crucial role here, as it helps researchers identify instruments that have already been tested and proven to be reliable. Using a known instrument not only saves time and effort, but also improves the overall quality of the research by reducing measurement error. From the perspective of validity, the focus shifts to whether the value observed and recorded truly reflects the concept and dimension of interest. This is assessed by comparing the measurement results with other relevant data, theories, or similar measurement processes. As with reliability, every researcher must either adopt an existing validated instrument or test and demonstrate the validity of a newly developed tool. Again, the literature search becomes a major advantage, as it allows researchers to locate instruments that have already been validated in previous studies. Using such established instruments strengthens the credibility of the research and increases confidence that the data genuinely represent the intended concept. Together, reliability and validity ensure that research measurements are both consistent and meaningful. This slide explains reliability by showing that every measurement consists of two components, which are the true score and error. The true score represents the actual value of the object or phenomenon being measured, while error represents unwanted variation that comes from the measurement process itself. When a measurement tool is unreliable, it introduces more error into the results, making it difficult to determine the true score accurately. As a result, unreliable measurement tools weaken the quality of research data. Reliability can be improved by using a better measurement tool or by refining the measurement method so that error is reduced. One of the simplest ways to assess reliability is through the test-retest approach. This method involves administering the same measurement to the same subjects at two different points in time and examining whether the results remain consistent. Test-retest reliability can be used whenever the act of measuring does not itself change or influence the data being collected. To evaluate the results, researchers calculate the correlation between the first set of scores and the second set of scores. A high correlation indicates that the measurement produces consistent results over time, while a low correlation suggests that the measurement contains a high level of error and is therefore unreliable. This slide emphasizes that the main goal of reliability is to reduce error in measurement. When measurements are reliable, researchers are better able to test their theories and hypotheses with confidence, because the data accurately reflect the phenomenon being studied rather than noise introduced by the measurement process. As the level of error in the data increases, whether the error is random or systematic, the likelihood of identifying true and meaningful results decreases. High levels of error can hide real relationships between variables or create misleading patterns that do not reflect reality. This makes it difficult for researchers to draw valid conclusions or support their hypotheses. Because of this, researchers place great importance on developing reliable measurement instruments. In fields such as psychology and human services, researchers often spend months or even years refining sets of questions, tests, or observation tools to ensure that they produce highly reliable results. This long development process reflects the understanding that strong research findings depend heavily on the quality and reliability of the measurements used. This slide explains several common sources of unreliability that can affect research measurements. One major source of unreliability occurs when the meaning of questions is unclear, causing respondents to interpret them differently or give random answers. When questions are vague or confusing, respondents may guess, misunderstand, or respond inconsistently, which increases random error in the data. Another source of unreliability arises when some questions or items measure a subtly different dimension and do not truly go with the others. In this case, the items are not aligned, and the measurement no longer behaves consistently as a single instrument. Unreliability can also occur when instructions are unclear or inconsistent, even if the questions themselves are well designed. If respondents do not fully understand how to answer the questions or are given different instructions, their responses may vary unnecessarily. Finally, outside events or external conditions can affect responses, especially when data are collected at different times or under different circumstances, leading to inconsistent results that are not related to the concept being measured. For example, imagine the colorful ice cream shown on the slide represents a questionnaire. If the flavors are mixed randomly without a clear theme, respondents may react differently each time, just as unclear questions lead to random answers. If one scoop is chocolate, another is chili, and another is cheese, they do not go together, similar to questions that measure different dimensions instead of one clear concept. If people are told different ways to eat the ice cream, such as some being told to eat quickly and others slowly, the experience will differ, just like inconsistent instructions affect responses. If the ice cream melts because of hot weather or is eaten in a noisy environment, the experience changes due to outside factors, just as external events can influence research responses and reduce reliability.